In this video, we're going to talk about how to graph polar equations of conic sections. So let's start with this example. Let's say that r is 6 divided by 2 minus cosine theta. Sketch the graph and determine the eccentricity of it. Now, there's two forms you need to be familiar with. R can equal ED divided by 1 plus or minus E sine theta, or it can equal ED over 1 plus or minus E cosine theta. E is the eccentricity of the graph. Now, if E is between 0 and 1, then the conic section is an ellipse. If E is equal to 1, then we have a parabola. If E is greater than 1, then it's a hyperbola. Now there's 4 variations that you need to be familiar with. So here's the first one. R equals ED divided by 1 plus E sine theta. The origin, also known as the pole, this is going to be the location of the focus. Now for this particular graph, it's going to open towards the focus in the downward direction. And above it, you have the directrix. The distance between the directrix and the focus is known as d. And so that's the d in this equation. E is the eccentricity. So in this case, we have a horizontal directrix above the pole. And the focus is the pole, which is the origin. Now the next one is r equals ED divided by 1 minus E sine theta. So once again, we're going to place the focus at the origin. But this time, the graph is going to open upward as opposed to downward. And the directrix is going to be below the pole. And we still have a horizontal directrix. And so you could say that the directrix is y equals negative d. It's d units below the focus. For the first one, it was y equals positive d. But for this one, it's negative d. Now the next two are these two equations. ED divided by 1 plus E cosine theta. And the other one is ED over 1 minus E cosine theta. So if we have positive E cosine theta, it's going to open towards the left, with the focus being at the origin. So the directrix is vertical this time, and it's to the right of the pole. And the equation is going to be x equals d. For this one, the conic section will open towards the right. And the directrix will be x equals negative d. Now let's go back to this equation. R equals 6 over 2 minus cosine theta. So the first thing I want to do is identify which of those 4 equations I have. And so I'm going to have this one, ED over 1 minus E cosine theta. Now what I want to do is turn this number into a 1. So that's the first thing I'm going to do. To do that, I need to multiply the top and the bottom by 1/2. Half of 6 is 3. Half of 2 is 1, and I'm going to have minus 1/2 cosine theta. So now I can clearly see that E is 1/2. So if E is 1/2, what type of conic section do I have? Is it an ellipse, a hyperbola, or a parabola? Because E is between 1 and 0, the conic section is an ellipse. So that gives me a good idea of how to graph it. Now the next thing I need to calculate is d. So this is equal to E times d. and e is 1/2. So I'm going to multiply both sides by 2. 2 times 3 is 6, 1/2 times 2 is 1, so d is equal to 6. So now let's graph it. Keep in mind that e is 1/2, d is 6. So for this particular graph, with the focus at the center, and then we have a negative cosine. So when dealing with cosine, it opens either to the left or to the right. But if you see negative cosine, the graph is going to open in this direction. So we have an ellipse, which means it's going to look like this. That's a rough sketch. And then the directrix is going to be on this side. Now what we need is some points. So we need 4 points. I'm going to highlight those points in green. So these are the 4 points we need to calculate. Now keep in mind, we're dealing with polar coordinates as opposed to rectangular coordinates. So we're going to be focused on r and theta. Let's call this point A, B, C, and D. At point A, theta is 0 degrees. At point B, theta is pi over 2. At point C, theta is pi. Point D, 3 pi over 2. And then A is back with 2 pi. So let's make a table. So I'm going to plug in 0 degrees, pi over 2, pi, and 3 pi over 2 into this equation. So when theta is 0, what is r? So it's going to be 6 over 2 minus, now cosine of 0 is positive 1. So this becomes 6 over 2 minus 1, which is 1. So r is equal to 6. Now what about when cosine is pi over 2? Cosine pi over 2 is 0. So we get 6 divided by 2, which is 3. Now what about cosine pi? Cosine pi is negative 1. 2 minus negative 1 is 2 plus 1, so that's 3. 6 over 3 is 2. And then cosine 3 pi over 2, that's 0. So 6 over 2 is 3. Now let's go ahead and graph it. So the majority of the graph will be on the right side. So the first point is at 0, 6. So theta is 0, which means it's on the x-axis, and r is 6, so we need to go 6 units in this direction. Now at pi over 2, which is the y-axis, let me just put that. So this is pi over 2, 0, pi, 3 pi over 2. R is 3, so we're going to go 3 units away from the center. And at pi, which is the negative x-axis, we need to go 2 units away from the center. And at 3 pi over 2, r is equal to 3. And now we can make a graph of the ellipse. And so that's just a rough sketch of the ellipse that we have. Let's see if I can make it look better. Now we need to plot the directrix. It's d units away from the focus. And so for this type of equation, if you have a negative sign, it's going to be x equals negative d. And we can see that d is 6, so it's x equals negative 6. So we need to extend the left side. So it should be over here. And so that is the equation of the directrix. And so that's how you can plot this particular ellipse. So we have the point 6, negative 2, 3, and negative 3. Now when dealing with ellipses, sometimes you may need to determine the length of the major axis and the length of the minor axis. So what is the length of the major axis? It's the distance between these 2 points. So the major axis is horizontal, and if we subtract 6 by -2, that will give us 8. So it's 8 units long. The major axis has a length of 2a. So a is going to be 8 over 2, so therefore a is 4. Now, how can we determine the length of the minor axis? So this is b, which means that this entire length is 2b. If we could find b, we could find the length of the minor axis. So how can we determine that? Now, e, the eccentricity, is c over a. The eccentricity is 1/2, a is 4, so we can calculate c. If we cross multiply, it's going to be 2 times c equals 4 times 1. So c is 4 over 2, which means c is 2. Now, for ellipses, c squared is a squared minus b squared. C is 2, so c squared is 4. A is 4, so a squared is 16. And now we need to solve for b squared. So I'm going to move negative b squared to the left side, so it's going to be positive b squared. And I'm going to move the 4 from the left to the right, where it's going to be minus 4. So b squared is 16 minus 4, which means b squared is 12. And so b is the square root of 12. And the square root of 12 is the square root of 4 times the square root of 3. And the square root of 4 is 2. So b is 2 square root 3, which means that the length of the minor axis, which is 2b, it's equal to 4 square root 3. So now we have the length of the minor axis and the length of the major axis, which is 8. So now that you have a, b, and c, you can do anything else that you want to do. Also, keep this in mind. The distance between the vertex, or one of the vertices of the ellipse, and the focus is 2. And so that's c, which means that for this ellipse, there's another focus here. But the focus that we're focused on is the one at the pole. So c is the distance between the vertices and the foci of an ellipse. Now, what if we wanted to find the rectangular equation of this ellipse? How can we do so? We need to know the values of a, b, and the center of the ellipse. So the center of the ellipse is here. It's the midpoint between -2 and 6. -2 plus 6 is 4, divided by 2 will give us an x-coordinate of 2, and the y-coordinate is 0. So the center is at 2, 0, a is 4, and b is 2 square root 3. The major axis for this particular ellipse is horizontal, so therefore the standard equation is x minus h squared divided by a squared plus y minus k squared over b squared equals 1. So we can see that based on the center, h is 2, k is 0. So it's x minus 2 squared over a squared. A is 4, so a squared is 16. And then y minus 0 squared, or simply just y squared, over b squared. Now, b is 2 square root 3, so if we square that, 2 squared is 4, and the square root of 3 squared is 3, so 4 times 3 is 12. B squared is 12. And so this is the rectangular equation of the ellipse. Let's move on to our next example. So let's say that r is 4 divided by 1 plus cosine theta. Go ahead and sketch the graph of this equation. So it's in the form ED divided by 1 plus E cosine theta. So we already have a 1, which is good. Therefore, the number in front of cosine is E. Since we don't see a number there, it's a 1. So E is 1. Now, E times D is 4. And since E is 1, that means D is equal to 4. So what type of conic section do we have, since E is equal to 1? If e is equal to 1, we have a parabola. Now, in what direction will the parabola open? So we have the focus at the center, and we have positive cosine, which means that it's going to open towards the left. So this is the general shape of the graph that we have. In order to sketch it, we need 3 points: the y-intercepts and one x-intercept. So we need theta equals 0, pi over 2, and 3 pi over 2. So let's make a table with those 3 values. Using this equation, when theta is 0 degrees, what is r? Cosine 0, that's 1. And so 1 plus 1 is 2, 4 over 2 is 2. Now what about when theta is pi over 2? What is the value of cosine pi over 2? Cosine pi over 2 is 0, so this becomes 4 over 1, which is 4. And when theta is 3 pi over 2, cosine 3 pi over 2 is 0, so we get the same r value. So now let's go ahead and sketch this graph. So the first point is 0, 2, or 2, 0 in polar coordinates. We got to write it like this. So at an angle of 0 degrees, which is the x-axis, the r value is 2. So we're going to travel 2 units away from the center along the positive x-axis. Now the next point is at pi over 2 with an r value of 4. And then at 3 pi over 2, the r value is also 4. And here is the focus, and the parabola is going to open in that direction. So that's the general shape of the parabola. Now we need to find the equation of the directrix. So we said d is 4, and for this particular type of shape, the directrix is going to be x equals d. So therefore I'll write it here, x equals 4. So we're going to have a vertical line at x equals 4. Now in rectangular coordinates, you've learned that p is the distance between the focus and the vertex of the parabola. P is also the distance between the directrix and the vertex. And this distance here, that's 2p. Now how can we write an equation of this parabola using rectangular coordinates, x and y? So we need to know the vertex, which is 2, 0, and we need to know p. Because it opens towards the left, p is negative 2 as opposed to positive 2. The standard form of the equation that we need to use is going to be y minus k squared, and that's equal to 4p times x minus h. So the vertex is h comma k. So h is 2, k is 0. So this is going to be y minus 0 squared, or simply y squared, and that's equal to 4p, or 4 times negative 2, and then x minus h, which is x minus 2. So then we have y squared is equal to negative 8 times x minus 2. So this is the equation of the parabola in rectangular form. Now let's try this example. Let's say that r is 10 divided by 2 plus 3 sine theta. So let's go ahead and graph this particular conic section. So let's recognize the form that it's in. So this is r equals ed over 1 plus e sine theta. So what is e and d in this example? So first, let's turn the 2 into a 1. And so let's multiply the top and the bottom by a half. Half of 10 is 5, half of 2 is 1, and then we're going to have plus 3 over 2 sine theta. So therefore, we can see that E is equal to 3 over 2. So what type of conic section do we have if E is greater than 1? If E is greater than 1, then we have a hyperbola. Now, what is the value of D? In this form, we can see that ED is equal to 5. And we know that E is 3 over 2. So let's multiply both sides by 2. 2 times 5 is 10. So 10 is equal to 3D. And then let's divide by 3. So D is 10 over 3. So let's start with a rough sketch of the graph that we have. So as I mentioned before, we have the form ED divided by 1 plus E sine theta. And we have the focus at the pole or at the origin, and the hyperbola is going to open in this direction, in the downward direction. And we're going to have a horizontal directrix above the pole. Now, since we're dealing with a hyperbola, there's going to be another portion of it going up in this direction. And we can sketch it using symmetry. So if we can get this one, then using symmetry we can sketch the one above it. So there's 3 points of interest. We need to find the 2 x-intercepts and the y-intercepts. And so the angles that we need to use are 0, pi over 2, and pi. There's nothing at 3 pi over 2, so we're not going to worry about that. If we do plug in 3 pi over 2, we could get this point. But we don't need to, because we could find that point using symmetry. So let's go back to this equation. R is equal to 10 over 2 plus 3 sine theta. So let's get all 4 points. 0, pi over 2, pi, and 3 pi over 2. So when theta is 0, what is R? Sine of 0 is 0, so it becomes 10 divided by 2, which is 5. Now what is sine pi over 2? Sine pi over 2 is 1, and 2 plus 3 is 5. 10 over 5 is 2. Sine pi is 0, so this is going to be 5 again. Now what about 3 pi over 2? Sine 3 pi over 2, that's going to be negative 1. So then we have 2 minus 3, which is negative 1. And so the whole thing is going to be negative 10. Now let's put this together. So I'm going to go by 2s. This is going to be 2, 4, 6. And so 2, 4, 6, 8, 10, 12. So this is 0, pi over 2, pi, and 3 pi over 2. So let's plot this point. R is 5, theta is 0. So theta is 0 on the x-axis, and this is going to be a value of 5 units away from the center. Now at pi over 2, R is 2, so that's going to be this point. And then at pi, R is 5. And at 3 pi over 2, R is negative 10. If R was positive 10, this would be 3 pi over 2. We would go 10 units that way. Because it's negative 10, we need to go 10 units in the other direction. So that gives us the first point of the upper part of the hyperbola. Now let's go ahead and draw a rough sketch. So that's the lower part. Now for the upper part, we need to use symmetry to sketch it. So going from this point to this point, we need to travel 5 units to the right and down 2 units. So we're going to do the same thing. So we're going to travel 5 units to the right, but up 2 units. So that's going to give us the point 5, 12, which should be somewhere in that region. And then if we do the same for the other side, it's going to be negative 5, 12. So that's it for the graph of this hyperbola. Now let's talk about the directrix. For this type of equation, it's y equals d, or y equals 10 over 3. 10 over 3 is about 3.33. And so that's somewhere between 2 and 4. So that's the location of the directrix. And here we have the focus. Now let's write a rectangular equation for this hyperbola. So we need to calculate A, B, and C. Notice that the center of the hyperbola is the midpoint between these two vertices. So this is at 2 and this is at 10. The midpoint of 2 and 10 is basically the average of the two numbers. 2 plus 10 is 12. 12 divided by 2 is 6. So the center of this hyperbola is located at 0, 6. Now the distance between the two vertices is the major axis. And so the length of the major axis is 2a, and 2a is going to be the difference between 10 and 2. So the major axis is 8 units long. So a is going to be 8 over 2, which is 4. So keep in mind, a is the distance between the center and the vertices. So between 6 and 2, that's 4 units. Now let's determine the value of b. So e is c over a, and e is 3 over 2. A is 4. So if we cross multiply, we have 3 times 4 equals 2c. And so 12 is equal to 2 times c. 12 divided by 2 is 6, so c is 6. And c is the distance between the center and the focus. And we can see that it's 6 units apart. This has a y value of 0 and this has a y value of 6. So c is 6. Now that we have a and c, we can calculate b. For a hyperbola, c squared is a squared plus b squared. Since c is equal to 6, c squared is going to be 36. And since a is 4, a squared is 16. So b squared is 36 minus 16, which is 20. And so b is going to be the square root of 20, which is the square root of 4 times the square root of 5, and the square root of 4 is 2. So b is 2 square root 5. So we have a, b, and c. So a is 4, b is 2 square root 5, a squared is 16, b squared is 20. And the center is 0, 6. Now for this particular type of hyperbola where it opens up and down, we can use this standard equation, y minus k squared over a squared minus x minus h squared over b squared is equal to 1. H is 0, k is 6. So it's going to be y minus 6 squared over a squared, which is 16, minus x minus h, or x minus 0, which is just x. And then b squared is 20, and that's equal to 1. So this is the rectangular equation of the hyperbola. So now that you know how to sketch a polar equation, you need to be able to write them given certain information. So let's start with this problem. Write a polar equation of a conic section with eccentricity 5 over 4 and directrix y equals 7. So let's plot the directrix first. So let's say this is y equals 7. What this means is that the conic section is below it, and it's going to point downward, or open downward rather. So what type of polar equation corresponds to this type of shape? Well, because it's going down, it has to be sine and not cosine. So it's ED divided by 1 plus E sine theta, since the horizontal directrix is above the pole. Now all we need to do is plug in E and D. So keep in mind the directrix is y equals d. So that tells us that d is 7. And we already have E. Now because E is greater than 1, we know that this particular type of conic section is a hyperbola. So there's another part of the graph that will open upward in that direction. But we don't need to worry about that. So E is 5 over 4, D is 7, and so this is what we now have. Now at this point, I recommend multiplying the top and bottom by 4 to eliminate all the fractions. So on the top, we can cancel the 4. And so in the numerator, we're going to have just 5 times 7. On the bottom, 1 times 4 is 4. And then 4 times 5 over 4, the 4's will cancel, leaving 5 sine theta. So the final answer is r is equal to 5 times 7, which is 35, over 4 plus 5 sine theta. And so this is the polar equation with eccentricity 5 over 4 and the directrix y equals 7. Now let's work on a similar example. Write a polar equation of a conic section with eccentricity 1/2 and directrix y equals -4. So let's start with a rough sketch. Let's plot the directrix. So this time it's going to be below the x-axis, which means the conic section is opening upward in this direction. And so here's the focus. Now because E is 1/2, E is less than 1, and when E is less than 1, or rather more specifically between 0 and 1, we have an ellipse. And so the shape of that ellipse will look something like that. Now for this particular type of shape, the equation that we need to deal with is ED over 1 minus E sine theta, because the directrix is below the pole. Now E is 1/2. Now what's D? This equation is y equals -4. And for this particular type of shape, the directrix is y equals -d. So we could set -d equal to -4. So if that's the case, if you multiply both sides by -1, d is 4. Now to get rid of the fraction, let's multiply the top and the bottom by 2. So 1/2 times 2 is 1. And so we're going to get 4 on top, and then 2 minus 1 sine theta, or simply sine theta. And so this is the answer. Write a polar equation of an ellipse with vertices 2, 0 and a, pi. Go ahead and try this problem. So let's begin with a sketch. And so these coordinates are polar coordinates in the form r, theta. So this is when theta is 0 degrees, and the negative x-axis corresponds to pi. So we have the point 2, 0, so when theta is 0, r is 2, and a, pi. So r is 8 when theta is pi. So we have an ellipse that looks something like this. So we're going to say that we have a conic section that opens in this general direction, with the center being the focus. So therefore, we need to use this particular polar equation, ED over 1, and then because it's going towards the left, we need to use cosine, but it's going to be positive E cosine theta. The directrix is going to be to the right. to the right of the pole. And so that's going to be x equals d. Now somehow we need to determine E and D. How can we do so? In terms of rectangular coordinates, this has an x value of 2 and that has an x value of -8. So therefore, this particular ellipse has a major horizontal axis length of 2 minus -8, which is 2 plus 8, so that's 10 units long. And the major axis is equal to 2a. So 10 divided by 2 is 5. So a is equal to 5. Now what is C? First, we need to identify the center. And that's the midpoint between -8 and 2. -8 plus 2 is -6 divided by 2, so that's -3. The distance between the focus and the center is our C value. And so we could say that C is equal to 3. The eccentricity is C over A. So C is 3, A is 5. Therefore, the eccentricity is 3 over 5. Now, what we need to do is determine D somehow. How can we determine D? At this point, we can get rid of the graph. We don't need it anymore, now that we have the eccentricity. So keep in mind the values of r and theta that we have. When theta is 0, r is 2. And when theta is pi, r is 8. So right now, the eccentricity is 3 over 5. And so we have this equation. To get rid of the fraction, let's multiply the top and the bottom by 5. So we're going to get r is equal to 3d over 5 plus 3 cosine theta at this point. So now we can solve for d. Let's use the point 8 comma pi. So r is 8 and cosine is pi. Cosine pi is -1. 5 plus -3 is +2. If we cross multiply, we'll get 3d is equal to 16. And so dividing both sides by 3, we can see that d is 16 over 3. So now let's plug that into this expression. So that's going to be 3 times 16 over 3 over this stuff. And so the 3's will cancel, and we could write the final answer for this problem. So the polar equation for this particular ellipse is r equals 16 over 5 plus 3 cosine theta. And so this is the answer. Now to check it, let's see if we'll get the second point. So let's plug in 0 for theta. Cosine of 0 is 1. And 5 plus 3 is 8. So we're going to have 16 over 8, which is 2. So that will give us an r value of 2. Therefore, this equation works. And so that's it for this example. Write a polar equation of a parabola with a directrix of x equals 6. So let's begin by plotting the directrix. So this is going to be somewhere on the right side. And we're going to have the focus at the center as always. And so the parabola is going to open towards the focus, but away from the directrix. So it has to go towards the left, which means that the equation that we're dealing with is ED over 1 plus E cosine theta, since it's going towards the left. If it was going towards the right, it would be minus E cosine theta. Now, for the directrix, we know that x is equal to d. So that tells us that d is equal to 6. And by definition, what do you think the eccentricity of an ellipse is? I mean, not an ellipse, but of a parabola. For a parabola, the eccentricity is always 1. So E is 1, D is 6. So the answer is going to be r equals 6 over 1 plus cosine theta. And this is the equation of the parabola. That's it. Number 5. Write a polar equation of a parabola with vertex 2, pi. So the angle is pi. This is 0, pi over 2, pi, and 3 pi over 2. At pi, r is 2. And so this is the vertex. The focus, by definition, will be at the origin, and so the parabola has to open towards the focus, which means the directrix is on this side. Now for a parabola, the distance between the directrix and the vertex is p. Also, the distance between the focus and the vertex is p. And this part is 2p. But we don't need to worry about that in this problem. Now, for a parabola, we know by definition e has to be 1. Now, what is the equation for the directrix? We know this is 0, this is -2 as an x-coordinate, so therefore we can say that p is 2 units long. Therefore, this must be -4. So the equation of the directrix is x equals -4. So in this form, it's x equals -d, which means that d is 4. And so we have this particular polar equation, ed over 1 minus e cosine theta, since it opens towards the right. So e is 1, d is 4. So the answer is going to be r equals 4 over 1 minus cosine theta. So that's the polar equation for this particular parabola.